As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. For this flight, it's time to head home.
And what comes after the International Space Station once its mission is over? How do we ensure the presence of humans in space?
Well, that's a great question. The plan that NASA has is to build a rocket called SLS, which is a heavy lift rocket. It's something that is much bigger than what we have today, and it will be able to launch the Orion capsule with humans on board, as well as landers or other components to destinations beyond Earth orbit. Right now, we only can fly in Earth orbit. That's the farthest that we can go. And this new system that we're building is going to allow us to go beyond and hopefully take humans into the solar system to explore. So the moon, Mars, asteroids, there's a lot of destinations that we could go to, and we're building these building block components in order to allow us to do that eventually.
Through the history of space exploration so far, we've debated where the Earth's atmosphere ends and space begins. And your surprise for the day is that according to newly unearthed observations, our atmosphere is way bigger than we ever thought. Like, it goes past the moon. It means that technically our most commonly defined line of where space begins is still in Earth's atmosphere. And then finally, there's the exosphere, that final layer between us and outer space, made up of super spaced out hydrogen and helium atoms, slowly dissipating out to nothing, up to 200,000 kilometers away from Earth's surface. Or so we thought. We actually haven't previously really known where the exosphere ends and outer space begins. We just know that those extremely sparse gases gradually fade out into a vacuum. But a team of astronomers has recently dropped a total bombshell. When the cloud of gases in the exosphere reflects the sun's UV light, it creates a luminosity, a glow that we can see called the geocorona. These new observations of the geocorona indicate that the exosphere may extend up to 630,000 kilometers away from Earth, a distance that includes the moon. So technically, the moon is in the Earth's atmosphere.